Moodle today. After this class, actually, I'm free.
Which one? Where?
Just more exams.
Where?
At the Moodle, at the bottom of Moodle.
Oh, there.
I'll make a zip file. You know zip? Yeah? Yeah.
Can you make the video in the picture? Can you make our video in the same group? Because it's very difficult to find all of them. Some is like the semester 1 students, the video is mixed with.
Maybe. Let me have a look.
Or maybe you can like make a list of the topic, which.
Maybe.
Please.
I don't know. Let me see.
Because
Let me see.
I entered some class and I see the video is too messy.
Let me see. What did I give you? I'm confused now. Let me see. Physics. 2014? No, 2015.
14 and 15.
14, 15.
Yeah.
Hang on, let's have a look here, great, Amanda. Come on.
But at least your voice and picture thing.
At least. Slow. Is this the exam I gave you?
Yeah. It's the same. I saw the 8 questions.
You know, yes. Right. Now, Amanda.
Oh.
Look here. Come on. See this little button?
Yes.
Click that, and then type in, for example, physics, bar, and then mechanics. You see?
Yeah.
And these are your videos because they're from 5 months ago. Mechanics.
Yeah, some video is for semester 1.
Yeah, what do you want? Semester 1?
I want semester 2 video.
Okay. Like atoms.
Some topic I don't know. Maybe I missed some topics, so I want to make a list and then I check which I missed. Yeah.
There's atoms, yeah. If I put in quotation marks. Atoms. Do you want a list of the topics so you can look them up?
Yeah.
No problem. Are you free after this class? How long are you free for? Have you got one class free?
Huh?
After this class? How much free time do you have?
Until 1:40.
Yeah,
Okay, no problem. After this class, we can print out a list of the topics, then you can check them. Yeah. Alright. What am I doing? The exam. Okay. How was the first question?
Okay.
Yeah?
But I think C1 I did some mistakes, so
I can skip the first part, can't I?
yeah.
Yeah. So the next part then is A man attempts to swim across a river is 15 meters wide. It's 15 meters wide. The man swims at a speed of 1.4 relative to water, but the river flows in a direction perpendicular to the river bank at a speed of 5.6. That's actually a mistake. That should have said parallel, because you all know that rivers flow like this, not like this. Yeah. Anyways, the river flows like this at a speed of 1.4 meters per second. No, the river is 5.6. And the man is 1.4. Yeah? So if you look at the man, he's going to go this way. The river will take him down with 5.6, and it will take him across, or he will take himself across with 1.4. So the question is, well, that's the first part. What is the velocity of the man? So this is the velocity of the man. He'll head 5.6 right and 1.4 north or up. In the exam, I guess you could write your answer like this: 5.6 meters per second horizontally, and 1.4 meters per second vertically. Yeah. Yeah, well, you could also find the speed and the angle here, but I don't think you have to do that. You're right, it seems odd that it's 3 marks. I feel like they made a mistake and they meant to ask you, like what Hareen said, was the speed and direction. Anyway, I'll find the speed and direction as well, but I don't have the answers for this exam, so I don't know. Where's my calculator? I just have this stupid one a student gave me.
This one looks good.
No, it's terrible. Oh, thank you. This will make life easier for me. What did you get, Hareen, for the speed?
I think I did it wrong, but I got what's my answer? 5.4.
Speed equals 5.77 meters per second, and the direction equals 14 degrees. Okay? Next now is determine the distance the man will have moved down the river before he reaches the other bank. So how far has the man travelled? So he'll go across like this. So you can do this as an X and a Y and a UVATS, UVATS, UVATS. So the U 5.6, 1.4, the V we don't know, the A is 0, the A is 0, the T we don't know, the S we don't know, but the S here we know is 15. So here, acceleration, the A is 0. The A is 0 because it's he's not falling. He's just in a river moving.
So it's different from jump.
Oh yeah, you're looking down. He's just in a river moving.
But acceleration not 9.81.
Oh, he's not falling. Yeah.
So if he moving on the ground is zero, it doesn't matter x or y. Seems like it's y here.
It's X and Y, but it's not X and Y like this. It's X and Y on the ground. Yeah.
So 2D.
2D on the ground, yeah. No height.
When the man crossed the river,
Yeah.
I think it's not constant speed.
Oh, it is.
Why?
Well, I might say it in the question. No, it doesn't.
No.
But it is constant speed because the river is not getting faster. It's the same speed. The man is not swimming harder. It's the same speed. Yeah. It's 0 because it's on the ground.
It's like the moment it like leaves his hand to the part where it lands on the ground. Same speed, right?
No. Why is this so confusing? I don't know.
Wait, one question is this V2.
Yeah.
What is the bank?
The bank is
Yeah.
here. These are the banks. Oh, come on, Andy.
The point is
So let's go down. No, the whole line is the bank.
at the end of the river.
The edge is the river. This is the bank.
And 2B and
Yes, 2A and B. It's okay.
yeah.
I don't know. Anyways, I'm continuing. So here, F equals UT. So T is 10.7. So I can put that in here. 10.7. 1.
Yeah, I get it now.
Do you? Are you sure? Okay.
So the question is not for density. You don't have to put how big it is.
No, hang on. No, because the A is 0.
Yes.
The question meant to say the river is parallel, because rivers move parallel. Rivers don't move across like this. They move down like this. S equals UT. So S equals 60. So this is 60. Yes. No, this is my final answer. So in the 10.71 seconds, the man went from here to here. He traveled 60 down the stream and 60 across the stream. So in total,
But I thought only the X you went 10.7.
yeah, the time is the same for both.
Wow.
This is the answer. How far he moved.
Distance is per level. And why do you write 10%?
Oh, I'm just showing you that that's the time from here to here. I don't need to. Yes. We're happy. Look how happy we are. We're very happy. Yes.
Did it happen in the exam?
This was last year's exam.
In the last year, but if we don't know the y-axis, the a is 0, so the whole question is wrong.
Maybe. Let's continue. Okay. Now, here's one you're more comfortable with. The ball is being thrown in the air. We all like this one, don't we? Yes, we do. You do. You told me you do.
I like, what's the word?
Which one?
Electricity.
Good. Kirchhoff.
Yeah, Kirchhoff.
A ball is thrown at a velocity of 18.6 at an angle 40 above the ground from a height of... Okay, so what you've got, here's the ground. Here's the ball. It's thrown at an angle of 18.6 meters per second, at an angle of 40 degrees, and the height, oh well, I guess it's not a person because he's not 9 meters tall. We'll make him something else. I don't know. We'll make it a cannon.
So it's on the ground?
What's wrong?
I think it's wrong.
No, it's not from the ground. It's from a height of 9.35. Yeah, so it'll look like, it'll look like this. But at the start,
Yeah.
is this your mistake?
No, I think I
You think you did it right? Okay, 9.35 meters is the starting height, yeah. Yeah? What's the maximum height? Okay, well that's not so bad. Maximum height is here. So, number one, how can I get the maximum height? Do I need to look at the x or the y?
Y.
Yeah. Let me put in the components here. So, what's the bottom one going to be? 18.6 cos 40, yeah. So that's 14.25 meters per second, and then the other one's 18.6 sine 40. 11.956 or 96 meters per second. So for maximum height, U, V, A, T, S, U 11.96, V 0, A minus 9.81. Which equation should I use? Let's see, V equals S equals V squared maybe. No, I think V squared. V squared equals U squared plus 2AS. 0 equals 11.96 squared minus twice 9.81 S. So I get S is 7.29 meters. So the height, that's not the final answer, is it though? Yeah. Plus 9.35. 16.6 meters. How'd you get 1.7? No, not good enough, I'm afraid. That's fine. Okay, is that okay? I would hope so. 2. What's the time to reach the maximum height? Well, then it's the same. Now we'll use V equals U plus AT. 0 equals 11.96 minus 9.81 T. So the T is 1.22 seconds. Yeah? Okay. 3. The total time for the ball to reach the ground here. So here we have U, V, A, T, S. The U, 11.96. The V, we don't know. The A, minus 9.81. The T is what we want. And the S, what's the S? Very good, minus 9.35. What did you say? S equals UT plus a half AT squared minus 9.35 equals 11.96 minus 9.81 over 2T squared. So you get 4.905 T squared minus 11.96 T minus 9.35 equals 0. You get two answers. Take only the first positive answer. T is 3.06 seconds.
What if the answer is 3?
The answer needs to be 3 significant figures. Yeah.
From math, does it have to be 3 or 4?
Yes.
3.
Now, determine the horizontal distance. So, U, V, A, T, S. The T, 3.06. The U is 14.25. The A is 0. We'll just do S equals UT. .6 meters. And finally, what's the kinetic energy of the ball as it hits the ground if its mass is 0.45? So the ball starts here, it has kinetic energy and it has potential energy, and when it hits the ground here it only has kinetic energy. This is what they want, but that's the same as this. So it's the kinetic energy at the start, which is a half m, and the speed is 18.6, half mv squared plus m g h. So that's the answer. That's a 4-5, by the way.
Does it not have to be negative 9.81 since it's moving down?
Not for potential energy formula, it's mgh just. All that's positive.
Number 4
Sure. There you go. Did you try the last part this way?
Yes, went to
How?
because my question 3 is wrong, so my 4, 5, 6.
What was question 3? The time?
At first I got wrong time, and from
But this should be right because this is given in the question. This is given. These are all.
I just potential energy at first equals to kinetic energy.
Ah, you forgot it also has kinetic at the start because it's moving. Yeah.
But why do we have the plus at the start? Because that means the kinetic energy for the first part half mc squared is the last part, right?
Both of this is for the start.
Why do we need the potential energy?
Because the energy at the end equals the energy at the start. The energy at the start is both potential and kinetic. Because it starts at a height. Yeah? Continue? Okay. What have we got next? So what's the answer to the first part?
I just write down A equals minus.
As the acceleration increases, the force increases, therefore the distance from the equilibrium position increases.
Yes, this is what I did.
Good. Minus omega squared x.
And the picture.
Very good on the picture. Which picture?
This is x and meter, and y axis is a and meter, mr squared, and going from middle and
Like cosine picture.
No, sine.
Like this?
Yeah.
I think we just need to make this time. Then it's fine. But I don't even think they want the graph because they said.
Just I forget the formulas or.
Okay, yeah. It just says how will the acceleration of the body vary. So like what Hareen said, that as the x increases, the a increases. What does the minus here mean? Yeah, but what does the minus do? So this is the origin. I'll draw that again. So this is going simple harmonic motion. So this is the x. So this is the a. So when the x is big, then the a is big. And the minus tells us that it's in the opposite direction. So when the x is big and positive, then the a will be big and negative. So actually I drew the a the wrong way. In my picture, the a should be going this way, of course. That's silly of me. So when the x is big and positive, the a is big and negative. I should draw that bigger. Well, it's heading to the left in this picture, yeah.
But then after that x gets big and then we like.
Oh, we don't know what's happening in the picture. Maybe it continues to get bigger. I don't. Maybe it's decelerating here. Yeah, probably decelerating. And then let's say here it's small and negative. Then the acceleration will be small. So here's small, and here is small x. The acceleration will be small and positive then.
How does it move?
In this picture, well, for example, maybe here it's slowing down. So it's moving out, and the spring is pulling it back, decelerating, like Karine said. And then maybe on this side, maybe it's being pulled in. So maybe the ball is going like this. It goes out, and then I look at it here, and it goes out, stop, then it comes back, then maybe it goes back, and now I'm looking at it here. Yeah, it's going left and right like this. Left and right, yeah. A sentence would be best, like your sentence, Hareen. But you get this from the definition as well. In other words, this question is asking for the definition of simple harmonic motion. Oh, Sophie, you look so unhappy. Good, I'm glad you're honest with me. Hareen, go with your answer. What was it?
As the acceleration increases,
Yeah.
the force increases. Therefore, the distance from the equilibrium position.
No, too fancy. So if we just focus on what they want is how will the acceleration of the body change with its distance from the equilibrium position. So as the distance increases, the acceleration will also increase, because acceleration is proportional to distance, and then you want to put in brackets
How do you say
proportional.
Proportional, can we just write a symbol?
That's what I did, the symbol, yeah.
Sometimes in exams you can't use it.
That's fine. There is a sign to the acceleration acts inwards. Opposite, yeah. Towards the center. In fact, the acceleration is proportional to equal to minus a constant times displacement. And this here is displacement. Now you don't have to write exactly that, but that should do the job. Great. Are you catching Pokemon in class?
No,
Good. There's no Pokemon in here.
actually, I'm Pokemon in chemistry. And it's high level.
Got this? You have a question from the exam? The rocket science question? What about it? Yeah, what's your question? Possible, but it's been a very long time since it was on the exam. The current person who writes the exam has not included it yet. So I think you'll have to go back like 6 years. So don't. No, I didn't say that. Just that he doesn't ask this question. If I was to guess, I would say no. But I don't know. I can't see the future. Okay, can I continue? Great. A 0.15 kilogram mass hangs at the end of the spring and causes the spring to extend by 5.64 times 10 to the minus 2. Okay. So in this picture, it extends by a distance of 5.62 times 10 to the minus 2 meters, and it's a mass of 0.15. there's a force pulling up on it. This force pulling up is equal to Hooke's law, and the force going down is equal to gravity, and if they're balanced, these should be equal. There's a force up and there's a force down. So you get Kx equals mg, so K equals mg over x. Let me double check for you. Let me double check. What did you get? 26?
Yes.
Oh good, I thought you said 36. So the K is 26.18 about, with 18 newtons per meter. Yeah? Okay. Next, it pulls down an extra 2.56 and vibrates. What is the time? How much extra is it pulled down? 2.56. Now there's a formula for this. Do you remember it? It's 2 pi root m over k. Thank you, that's better, yes. So this is 2 pi root m.
The m is just the mass, right? 0.15.
Correct. And k we have as previously. 0.4756 seconds, about. Yeah. Okay, next. What is the baby question. Frequency is 1 over t. For babies. 2.103 hertz. What's the maximum speed? Now, do anyone remember the formula for maximum speed? A omega, very good. And omega is 2 pi over t, so
What is the A?
hold on. Now, the A is in my picture. You can't see it right now. What did you get? No. Hang on, let me double check. The A is 2.56 times 10 to the minus 2. Oh, sorry, I typed it in wrong. You're right, Grace. 0.338 meters per second. Hareen, the A is this. It's in the question. The amplitude.
That it pull down further.
Yeah. From the equilibrium.
Has to be
From the equilibrium. The amplitude is the distance from the equilibrium. In the previous picture, it was an equilibrium. Oh dear.
Oh, but that means like at 5.64 times 10 to the minus 2, that's the equilibrium. In the system.
Yes. The amplitude is distance from the equilibrium. The acceleration when it is that far above the equilibrium. Now, you have acceleration equals. Now, he doesn't say in the question if it's going up or if it's going down. So I don't know if it's a plus or a minus. Yeah, but what I mean is it's minus omega squared x. But I don't know if the x is positive or negative. I mean, okay, oh yeah, no, sorry. Never mind. Don't listen to me. Minus 2 pi over t squared x. You have it? Great. Let me double check. the x is 0.95. What did you get? Yeah.
What is the what is the
Well, I got minus 1.658, so 66 is fine. Yes?
what if it's below the equilibrium position? Does it have to be minus 0.95 times 10 to the minus 2? Or
If it's below, the x would be negative. Yeah. What's the time taken for the mass to move directly from that position below the equilibrium to that position above the equilibrium? Right, now that one's a bit tricky. So it starts off here, a distance of 2. And then it moves up here, a distance of 2. And let's make our life easy and say that it starts here in the middle. Or, let's make our life even easier. It doesn't start in the middle. If you pull this down, where's the starting point? Down here, yeah.
isn't it the same?
Well, we'll try to keep it in line with the story. So it starts actually here, because someone pulled it down and then they released it. So for the x, do I use cos or sine? Yeah, cos. X equals a cos omega t.
Also the x is not minus 2 times 10 to the minus
Oh no, it is, yeah. Yeah, this is the x. So you get t equals x over a cos inverse 1 over omega when you solve it. Rearrange it for the t. This formula? Yeah, this is a formula. And it's cos because it starts at the end, and it was sine if it starts in the middle. Right, so the omega is 2 pi over t. So this will be t over 2 pi cos inverse x over a. What was my t? It was 4756. And the x is minus 2. Well, actually, I should be careful. If I'm saying it starts underneath, I should put a minus here. Yeah. So I'll put a minus here and a minus here because it starts under. You might still get, you'll still get the same answer maybe if you don't do that. We'll see. What was the A? The big A. 2.56. 10 to the minus 2. Make sure you're in radian mode. And the first time you get when you use this number is 0.18677 seconds. And then the second time, oh sorry, that's wrong. That's wrong. That's the second time. The first time when you use this, that second time was for this one, and the first time when you use the minus, you get 0.0510 seconds.
Well, it won't be the same.
No, because the first time is to go from here to here, and then the second time is to go from here to here. We want the difference. So the answer is 0.136 seconds.
Then you have to times 2, right?
No.
Because they want the time from there and go up and then come down back.
Did they say they wanted the time to go up and down? I don't think so. They just want the time to go from here, which is T1, to here, which is T2, and then I minus them. Is that okay? It is? Yeah. Here, yeah. So the first T1 is the time to go from the start to here. The second, the T2, is the time to go from the start to here with the positive. I minus the times to get the time to go from here to here. So the delta T is T2 minus T1. No.
What is from the bottom from to the positive?
It's from the bottom to the negative, and then the bottom to the positive. Yeah. Yeah? Okay. Continue. What's the next question? Oh, we're not finished yet. We're still... Alright, okay. Is this still question 1? Oh, it's question 2? Oh, thank goodness. I thought I was still on number 1. Right, C. Light has a frequency of 7.32 times 10 to the 13. Shines onto a sample of hydrogen bromide gas. It's found that this frequency is absorbed and it resonates. What is meant by resonant frequency? Alright, does anyone remember resonant frequency? Yeah, go on. I think you're just missing one word, maybe. No, that's fine, but the natural frequency, yeah. The frequency the atoms vibrate at, yeah. That's fine. So that's in your notes. Okay, what's the constant? So they want the constant. So T equals 2 pi root m over k, isn't it? So that means that T squared equals 4 pi squared m over k. So that means that k equals 4 pi squared m over t squared. Do we know the t? No. But we know that t equals 1 over f. And we know the f. So we can get k equals 4 pi squared mf. So what are we missing? What do we not know now? It's just the m, isn't it? But they tell us that the relative atomic mass of hydrogen is 1. Huh? Well, they want the k. So we know this, we know this, we know this. We just need to know the m.
Is the M 1?
No, because that's 1 kilogram. This is like with chemistry, with Avogadro's number. They're saying that 1 mole of hydrogen weighs 1 gram. But anyways, I don't really think I need to use this because if you remember, your calculator has the mass of a proton on it, and hydrogen is just 1 proton. Yeah, so we'll just put in that. So I get my answer is 4.83 times 10 to the minus 12 newtons per meter. Yeah, I think so. But The problem is, no, it doesn't matter.
No problem.
Well, there is a problem because it's not hydrogen. It says it's hydrogen bromide gas.
No, it says hydrogen. It says the bromine is constant.
What's it say about it?
The bromine is stationary.
Ah, so that's just like the origin then. Yeah, okay. So in the picture it looks like this. This is the Br, and this is fixed. And what's happening is the hydrogen, what's the hydrogen? It's just one proton, isn't it? This is the bond, and what the bond is like, it's like a spring. So what's happening is the hydrogen is going back and forth like this around the bromide. So we just care about the mass of the hydrogen because the bromide is like the wall, it's the fixed point. Now that's that's the answer, yeah. No, M is mass of proton. It's hydrogen, one hydrogen. Continue? Yeah? Okay.
Do we need the relative atomic mass of hydrogen?
You need it? You can, sorry. You need it if your calculator doesn't have mass of proton on it, because what they're saying is 1 mole of hydrogen equals 1 gram. Isn't that right, what you learned from chemistry? I know it's not exactly 1, or do you use 1 in chemistry? Yeah, it's like 1.0002, but it doesn't matter. So 1 gram, so 1 mole is this, so what's Avogadro's number on the calculator? It's
4.
yeah, you know it from chemistry, but what's on the calculator? 24. So what you can say is 1 Avogadro of hydrogen equals 0.001 kilograms. So 1 hydrogen, which is a proton, equals 0.001 divided by Avogadro, which equals 1.66 times 10 to the minus 28 kilograms. Yeah. But that's what, unless I have my understanding wrong, but you did this in chemistry. When it said the relative atomic mass of hydrogen is 1, doesn't that mean that 1 mole of hydrogen has a mass of 1 gram?
Yeah, but it also basically means that only in the nucleus there's only the total mass of the proton and the neutron is 1. And it's on the calculator, the given mass of proton is 1. So, and we know that hydrogen has 1 proton, so we can just use that.
Say again?
Because we know that hydrogen only has 1 proton, so we can just key in on the calculator.
1 proton. Yeah, but that's what I did.
That's what they want. I think that's why they wanted to give us that information.
You think this is completely wrong then? I agree with you. No, I agree with you. I think Hareen is right when they're saying that this here is just telling us that the hydrogen is just made of 1 proton, that there's no neutrons or anything like that. Think of it like this. They're saying that the mass is 1 AMU. Is that better? I don't know. Everybody just looks so unhappy with me. This here, relative atomic mass of hydrogen equals 1. They're saying that the mass of hydrogen is 1 AMU. You remember AMU? 1U. We did it last week. Yeah. Is that better this way? Okay. continue?
Yeah.
Great. Oh, okay. No, this is the answer. What's the next question about? Continue.
The ice becomes water and becomes gas.
The liquid water becomes gas. So latent heat is the energy required to change a
And it's to change the state of mass from liquid to gas and not change the
that changes temperature, yes. From liquid to gas. Okay. Sketch a graph showing the temperature against time of a block of ice. Okay, so from -5 to 105. Alright. So this is the temperature. Temperature in Celsius, and we'll say this is the time in seconds. We do it this way, yeah. And here this is -5, and this is 105. So it starts off at -5, and it gets warmer until it hits 0. And then what happens? It's flat, and then it melts, and now it's a liquid, and then warmer until it hits 100. Then it's becoming steam, and then it continues again. And they want you to write in the phase temperatures, which I did. Let me just mark that as 0. So here is an ice, here is melting, here is a liquid, why not? And here is boiling, and then finally it's steam, not like steam. Melting, yeah.
Do we have to write like T1, T2, T3?
No, this is fine. It's not bad for 3 marks. Continue. So what you have is 0.25 kilograms of ice, and it turns into steam. Okay, so that's pretty nice. You've got your ice, and its temperature, its mass is, its temperature is -5. Then it becomes ice at 0. Then it becomes water. That's water at 0. Then it becomes water at 100. Then what happens next?
Then that's it.
No, then it boils. Yeah, it becomes gas, but it's still 100. And then the last step becomes gas of 105.
No, it's only until 100.
Oh, it's only until 100.
Yeah.
Great. So I can stop the story here. And what do they want? The energy. So it's MC for ice, and then delta, and what's the delta here? 5. Then plus ML for this part here. Then plus MC for water times 100. Oh, that's fusion, the heat for changing it from solid to liquid. where am I in my story? I've done this one, this one, and this one. And now the water to steam. Vaporization. The M is 0.25 and the M is in common. So I can take the M out. M is 0.25. So I'm left with the heat capacity for ice, which is 2.1 times 10 to the 3. So that's 2100 times 5, plus latent heat of fusion, which is a big number. Is that 10 to the 5?
Yes.
1,2,3,3,4,000 plus 100 times heat capacity of water, which is 4,180. So that's 4,180. That's not an 8. 4,180 times 100. And then finally the latent heat of vaporization, which is, oh my goodness, 2.56 mega. 2.26? 2.26. Whew. 2.26. Don't confuse me. 226,000. Phew.
I got 6,426,25.
Is it right?
I hope.
What did you get, Grace? What did you get, Irene? 755,625. In your face, Irene. Why? I use my calculator, that's why.
I think you should write multiply times.
Yeah, we'll make it nice, will we? 1, 2, 3, 4, 5. Hang on. 1, 2, 3, 4, 5. Oh yeah, here, yeah. 756 kilojoules. I think so too. Continue. What's Boyle's law?
The pressure law.
Which one, Irene?
If volume goes up, the temperature goes up as well. The temperature goes up, the pressure goes up.
At constant Irish physicist. Did you know that? Boyle is an Irish physicist with gas, pressure and volume. Boyle said at constant temperature, that the pressure is inversely proportional to the volume. Ideal gas laws. Yes. So, if you think about it like this, if this is the volume and this is the pressure, as the volume increases, pressure decreases. So the graph is downward like this.
What is this graph called? Inversely proportional graph.
Yeah. Yes. Boyle was an Irish physicist. In fact, he is buried at the church near the school. If you wanted to go visit him, say hello. No.
He's buried. Why would he be alive?
Be dead about 300 or 400 years, so. Yes, indeed. In this classroom. Okay. Now, next one is you have oxygen. Let me close this, it's getting in my way. You have oxygen. What's the mass of the oxygen? 0.575 kilograms. The pressure is 1.51 times 10 to the 5 pascals. The temperature is 283.15 Kelvin, because in the question we're told it's 10 Celsius. And the molar mass of oxygen is 32. So that means that 1 mole equals 0.032 kilograms. The temperature is 10 Celsius. I thought you add 273.15 to make. Oh, I don't know. I'm using 0.15 to be more accurate. I can't remember what it is in your formula book. It'll be at the front of your book. What did they say? I mean, it shouldn't matter, because if I'm doing 3 significant figures, it shouldn't affect the answer. Okay, how many moles do I have? 0.575 divided by 0.032. I have 17.97 moles. Is that information okay? Oh, Lorraine's going to kill you. Oh, when she finds you. Yeah, it's this one, yeah, over this one. I won't tell Lorraine, it's okay. Can I continue? So what do we want first? The volume? B, okay.
The mole is 0.018.
Well, it says it right here, the molar mass, the relative molar mass of oxygen is 32.
Yeah, so you're just supposed to take the mass divided by the molar mass. 0.575 divided by 32. Why is it 0.032?
You're confusing me so much. This is set relative molecular mass of oxygen is 32. What does that mean?
Yeah, it means the mass of oxygen is 32. So if you want to
1 mole of oxygen is 32.
Yes.
Yeah, grams.
32 grams.
Yeah. So I have 575 grams. So if I divide that by 32 grams, that's how many moles I have.
My bad.
Yeah. Yeah, Hareen confused us. Yeah. Okay. The molar mass of oxygen is 32. So this means 1 mole of oxygen. What's its mass? 32 grams. That's what it means, isn't it? So, how many moles do we have? Well, it'll be 575 divided by 32. Because we have 575 grams of oxygen. Divided by 32 grams per mole gives us about 20 moles, isn't it? 18 moles about. Yeah. Is that okay? Right, so volume. PV equals N or T. So V is N or T over P. So V is, we'll double check, but it sounds good. What did you get? 0.28. Yes, 0.28 meters cubed. Yeah. What is the new volume if the pressure is increased? while the temperature stays constant. Super easy. What do? Just change the pressure in my formula. Just change this here. Okay, so what's the pressure now? What did it say it was? 2.51. Okay, what did you get? Yeah, 0.168 meters cubed.
Wait, how do you get the density? What did you do?
Just do it again with different pressure.
Oh,
Yeah.
but it's 0 degrees Celsius.
No, that's part 2. You're looking at part 3. Now we'll do part 3. What's the density? The temperature is 0 and the pressure is 1.01 times 10 to the 5. So, what's what? Standard temperature and pressure. Right, so first I'll get the volume. The pressure has changed. It's now 1.01 times 10 to the 5. And what else has changed in the last example? The temperature. Temperature and pressure has changed. So now the volume is 0.4039 meters cubed. So the density is the mass over the volume. It's given 575. .42 kilograms per meter cubed. I think that was a good question. Continue. Force confusion? Let's make.
I just you only have to
Okay. Let's make a beautiful graph. Not bad. We only have 2 questions left and then I'll give you another exam. Sophie, do you want to come see me after this class and I can print this exam for you? Yeah. Alright. This one? Oh, you have it? How do you have it?
I printed on
Okay. So then you don't need to share with.
No.
Okay. Okay. Come on. Right, so what do we need to do first? So first job is complete the table. Okay. So first we have time in hours. And then the next one is activity in megabequals. And then the last one is log the activity which is in megabequals. The time goes from 0 up in 4s until we have 24, is it? Is that right? It goes up in 4s? Yeah. And then the activity starts at 90, and then it decreases to 74.3. No, I had that upside down. Is the next one 60? No. 58.5. Ew. Okay, I'll copy it. 58.5. 49.1. 38.4. 31.9. 25.1. Okay. Alright, so the first thing is get the log. Well, that's for babies. Babies with calculators can do this. So I'm sure you can all do it. Yes. Log straight down. There you go. So that's easy peasy for 2 marks. The next one is a proof. And I said it's one of the few proofs on the course. I'll do the proof really quick. Activity equals activity 0 e minus lambda t. So log A equals log A0 e minus lambda t. Log A equals log A0 plus log E minus lambda t. Log A equals log A0 minus lambda t. So log A equals minus lambda t plus log A0. So this is like the M and this is like the C on the graph. This is like the X and this is like the Y.
What other proofs do we have to know yet?
I don't remember right now because I'm hungry. I had a small breakfast because I woke up late. Harren, I think I said there's 2 proofs. I think. Yeah, neither can I. This is one of them. No, maybe after I have something to eat I can remember. Nope, gone. Don't know right now. Okay, continue. What's next? Plot the graph. Okay, so we want to plot this and this. I remember. Kepler's third law. No, semester 2 with the fields. The one that has t squared in it. No, sorry, I think it's Kepler's second law. The one with the t squared in it. Fields. Kepler's laws. Kepler's 3 laws. Yeah. That one. Okay. What question is this? Question B4, is it? Yeah. Alright, so this is what the graph should look like as you know. Yeah, me too. Okay, so this is what the graph looks like. Isn't it beautiful? Yeah. Use the graph to calculate the decay constant. What's the decay constant on the graph? The slope, minus the slope. So you draw the triangle. Oh, sorry, oh, hang on. No. You're thinking of the electricity one where the time constant is 1 over the slope. In this lesson, the decay constant is the slope. The minus of it. So the constant here is 0.053.
Wait, so the lambda is the decay constant. Oh, yes, yes.
Because we can get it from Excel, but you know how to do it by drawing a triangle. What's the units for the K constant? You draw the triangle. It's minus the slope. Do you know what I mean?
Yes.
Yeah.
Minus
It's this, yeah, this divided by this.
1 over 2.
No. He said that. That's for electricity. That's a different thing. Minus. Yes.
Equals over.
No. What unit is the K constant?
Omega equals.
No. Look at where it is in the formula at the beginning. What unit is it? What unit is this? Nope. No. Oh my goodness, guys. What unit is this? No.
Give up.
It's usually per second, but it's not in this case. It's per hours because the question is in hours.
Oh, yeah.
Great.
What's the hour?
There are no Pokemon in your hair. Please stop looking at it. Did you get that? Because you were looking at your hair. The K constant is usually per second, but in this question it's per hours because the question is in hours. Yes? Okay. Continue. What's the next part? What is the half-life? Do you remember the half-life formula? What is it? Half-life? M squared over M squared? Log 2 over the K constant. The last part, yeah. So log 2 over 0.053, so that's 13.08, so 13.1 hours.
Cannot be 13.08 hours.
I can be. This is so not the thing to worry about. Continue? Right. And then a patient is given a drink containing iodine 123 in order to study the uptake of iodine by the thyroid. The initial activity is 11.2. So in this one, do you remember that picture I showed you with the man that has all the radioactive material inside him, and you can remember we could see it here, we could see it in his liver. Yeah, that's what happens here. Somebody's given a drink of this, and they want to know if what's the activity. The question is, what's the activity after 10 hours? That's what it is. So we can just use our formula. The formula is activity equals A0 E minus lambda T. Now, what's the lambda? I forget. 0.053. How many hours? 10 hours. Wait, there's a dirty trick with this question. I think it's rather dirty. Here, in the story it says 50% of the iodine has entered the thyroid after 10 hours. So it's like only half of it got here, and the other half is, I don't know, somewhere else, still drinking it, I don't know. So I shouldn't actually use 11.2 as the A0. It's like you only drank half of it, only half of it's here. So I need to divide my answer by 2. I think that's very sneaky. It's terrible, yeah. So here in my answer, or my A0, I have to divide by 2. So the answer is 3.296 megabequels. Yep. Determine the time taken for the patient taking the drink for the activity to fall to 2. Okay, so for the last part, they want to know how long until the activity is only 2 megabequels. And the answer is T equals 19.4 hours. Easy, I think, the last part. It's just a math problem, find the T. Yeah. We'll have waves and fields. So we'll get this finished tomorrow and we can start the next exam.
Question B5.
Yeah, we'll do that one. B5 and 6 we'll do in the morning. You want the new exam now? Sure. You can see me in 20 minutes after I have food. Tea. I think I'll have tea, yeah.
Are you going to upload another version?
I will upload other versions except